Uronic acid pathway. Uronic acid pathway is another minor alternative pathway for glucose oxidation by which glucuronic acid, ascorbic acid, and pentose are obtained from glucose, like hexose monophosphate shunt or HMP or pentose phosphate pathway (PPP) it does not need nor generate ATP.
Next is uronic acid pathway is an alternative oxidative pathway for glucose metabolism. It catalyzes the conversion of glucose to glucuronic acid, ascorbic acid, and pentoses. Also, it does not lead to the formation of ATP. So where does this alternative pathway actually work? Uronic acid pathway is sited in cytosol of many tissues, especially in kidney, liver, and intestine. Focusing in the liver, the uronic acid pathway catalyzes the conversion of glucose to glucuronic acid, ascorbic acid, which means accept in human beings and other species, for which ascorbate is a vitamin, vitamin C, and pentoses.
In steps of uronic acid pathway, actually we have two steps in a uronic acid pathway. The first one is formation of UDP glucose. UDP glucose is stand for uridine diphosphate. And the second one, we have the formation of glucuronic acid. So we go for the next slide. We go for the first part of formation of UDP glucose, which is glucose convert to glucose phosphate. Glucose are involved in the hexokinase glucose, which is catalyzed by hexokinase, an enzyme with broad specificity that catalyzes the phosphorylation of 6-carbon sugar. Hexokinase phosphorylates glucose using ATP as the sources of the phosphate to produce glucose 6-phosphate. So we go for the next one is glucose 1-phosphate. From the glucose 6-phosphate that convert to glucose 1-phosphate via phosphoglucomatase. And glucose 1-phosphate react with uridine triphosphate, which is UTP, via UDP glycose pyrophosphorylase to form UDP glucose. For the information, UDP glucose for pyrophosphorylase, which is in the short form UGP, is the only enzyme capable of activating glucose 1-phosphate to UDP glucose, which is a metabolite located at intersection of virtually all metabolic pathway in the mammalian cell. So, from the UDP glucose, we will convert to UDP glucuronic acid, which is UDP glucose is oxidized at carbon number 6 by a two-step process via an NAD plus dependent UDP glucose dehydrogenase to form UDP glucuronic acid.
So next, we move to the formation of glucuronic acid, which is the second formation. This glucuronic acid will be initially started when the UDP glucuronic acid that formed from UDP glucose formation will be converted to D-glucuronic acid. So firstly, this D-glucuronic acid will be converted to L-gluconate with the involvement of the glucuronate without this enzyme. Then this L-gluconate will be converted to L-gluconolactone with the involvement of the aldolactonase enzyme. This L-gluconolactone continuously will be converted to 2-ketogluconolactone with the involvement of the gluconolactone oxidase that's really deficient in human. Lastly, this 2-ketogluconolactone will be converted to L-ascorbic acid.
Next part is the regulation of uronic pathway. Administration of drugs such as chlorobutanol and barbital significantly increases the uronic acid pathway. Chlorobutanol is a chemical compound with a molecular formula C4H7ClO. It is an aromatic alcohol and a derivative of chloroform. It is used as a preservative in some pharmaceutical and cosmetic products, as well as topical anesthetic. It is also used as flavoring agents in foods, beverage, and tobacco. Besides, barbital is a barbiturate drug that is used as a sedative or hypnotic. It was formerly used as a sleeping pill or tranquilizer, but it has been largely replaced by newer drugs for these purposes. Certain drugs are also found to enhance the synthesis of ascorbic acid. Furthermore, ascorbic acid, vitamin C, can be synthesized in laboratory by reacting glucose with acetic anhydride in the presence of a catalytic amount of sulfuric acid. The reaction produces dihydroascorbic acid, which is then reduced to L-ascorbic acid by heating it in the presence of a reducing agent, such as sodium borohydride.
Moving to the next slide is the significance or importance of uranic acid pathway. As we all know, it is an alternative oxidative pathway for glucose. It concerns with the synthesis of glucuronic acid, pentoses, and vitamin ascorbic acid. This pathway also produces diglucuronic acid, which is required for detoxification of foreign chemicals and synthesis of mucopolysaccharides. It also provides UDP glucuronic acid, which is the active form of glucuronic acid. The next significance of uranic acid pathway is conjugation of bilirubin. Conjugation prevents bilirubin from passively being reabsorbed by the intestinal mucosa. It is due to its hydrophilicity and large molecular size. Thus, conjugation works to promote the elimination of potentially toxic metabolic waste products. Next is the synthesis of glycosaminoglycans or GAG. GAG plays a crucial role in the cell signaling process, including regulation of cell growth, proliferation, promotion of cell adhesion, anticoagulation, and bond repairs. Lastly is the conjugation of various drugs. Conjugation of various drugs will make them more water-soluble and more easily excretable.